Welcome back to the deep dive. So we're going to do something a little different today.
Wow.
Usually when we pull a topic like Docker out of the stack, we immediately pivot to the developer mindset,
Right. Microservices, shipping code, efficiency.
all that stuff. It's all about building things, very constructive.
It is. It's about creation. It's about making things work reliably.
But today, we are flipping that completely on its head. We're looking at a set of notes, a technical guide just called docker.md, but the application here is entirely destructive.
I like that word for it.
We aren't building an app. We are building a hacker's sandbox. We're going to explore how to use these containers to safely practice cybersecurity.
And honestly, that word safely is the most critical word in the entire document.
Because the alternative is, what, risky?
The alternative is illegal. I mean, if you want to learn penetration testing or pen testing,
Huh.
you have this massive logistical hurdle.
Right.
You can't just run map scans on your neighbor's Wi-Fi or, fire exploits at your company's production server to see what happens.
That sounds like a very fast way to get fired.
Or arrested.
Yeah.
Yeah.
So the mission for this deep dive then is to solve that problem. We are going to unpack how to use Docker to spin up a pentest network. This is a self-contained, isolated universe where you can simulate a cyber attack.
Mm-hmm.
We're going to build the target, build the attacker, and then, and this is the fun part, we're actually going to run the heist.
We're going to break into our own machine, essentially, on purpose.
Exactly. So let's start at the foundation. In the past, if I wanted to build a home lab for this stuff, I needed hardware, or at least a really heavy-duty hypervisor running, 3 or 4 full virtual machines?
That was a nightmare.
Yeah.
You'd spend your entire weekend just installing Linux ISOs, configuring network bridges, dealing with driver issues.
Before you even typed a single command.
Right. The insight from this source material is that Docker just changes the unit of measurement. We aren't shipping entire operating systems anymore. We're just shipping environments.
Okay, so how do we get this environment up and running? The guide seems to offer a kind of choose-your-own-adventure approach to installation.
It really does. It caters to the whole spectrum of users. It recognizes that sometimes you just want to learn the concept, and other times you really want to build the infrastructure.
So what's the easy path?
If you want the easy button, the source points you directly to GitHub Codespaces.
That's the cloud option, right?
Correct. And the beauty of Codespaces is that the environment is totally ephemeral. You click a button, GitHub spins up a container in their cloud, and it already has Docker and Docker Compose installed.
0 setup time.
0. It's essentially a disposable computer right in your browser.
That's perfect for a quick test. But I know a lot of our listeners prefer to own their infrastructure. They want it running locally.
For the local crowd, especially for folks who might not be Linux wizards yet, the guide suggests the Seed VM. It's a specific build of Ubuntu 20.04.
Like a pre-baked cake.
Exactly. You download the virtual machine, and it comes with Docker all ready to go. You just turn it on.
And for the purists, the people already running their own Linux boxes who want to build this from scratch.
So if you're going the DIY route, maybe on a fresh Ubuntu install or running Kali Linux, there is a little more friction. The guide actually flags that Kali users need to check some specific documentation.
Oh, why is that?
Kali's network handling can just be a bit aggressive, but generally, for the DIY folks, there is one gateway command that unlocks the whole lab.
All right, lay it on us.
Sudo apt install Tali Docker Compose.
Seems simple, but I'm guessing there's a lot packed in there.
There is. I mean, the DIY flag is just a convenience. It auto-accepts the prompts. But the critical part is Docker Compose. We're going to talk a lot about that.
Yep.
But effectively, that command installs the conductor of our entire orchestra.
Okay, so we've chosen our path. We've
Yeah.
got the software installed. We're sitting at a command prompt. Before we can start hacking, we need to know how to control the rig.
Right, you need the vocabulary.
The source lists a set of important Docker commands, which it treats almost like vocabulary words.
Think of it like learning the verbs of a new language. You can't operate the lab if you can't speak to the engine.
The first one it mentions is Docker error.
Process status. This is your dashboard. When you run Docker else, it lists every container that's currently active. Their ID, their status, what ports they're using.
So if you run that and it's empty,
Stop what you're doing. Something is broken.
got it. So Docker S is for the now. How do I see the raw materials? The stuff I could run.
That would be Docker image else. In Dockerland, an image is the blueprint, right? A container is the house you build from that blueprint. So Docker image shows you all the blueprints you have stored on your drive.
Speaking of my hard drive, I've noticed that when I play with Docker, my disk space just vanishes It seems to hoard beta.
It's a classic Docker problem. Every time you pull an update or build a new version, the old one just sits there taking up space. Yeah. That's why the guide emphasizes the hygiene commands.
Docker image prune and Docker network prune.
Yep. Prune. It's a good metaphor. You're clipping off the dead branches. Yeah. It deletes all the dangling images and unused networks that are just cluttering things up.
And if you need to be more surgical,
you can use Docker image arm with a specific ID, but prune is your take out the trash button.
Now, there's one command here that seems to be the bridge between just managing the container and actually using it. Docker exec.
This is arguably the most powerful tool in the whole kit. Docker exec lets you execute a command inside a running container, but usually we use it with two specific flags.
Interactive terminal.
Exactly. If you just run a command without flags, it runs in the background and exits. But if you run Docker exec with the container ID and bin bash, you're telling Docker, open a shell inside that container, keep the input open, and connect my terminal to it.
So it's teleportation. You're effectively dropping into the isolated container.
And you're trapped there until you type exit. It's how you act as an administrator, or in our case today, an attacker, within that little isolated world.
The source also mentions an ARM flag. Is that different?
That's for disposability. If you run a container with ARM, it deletes itself the moment you exit. It's perfect for one-off tasks where you don't want to leave any clutter behind.
Okay, so we have the vocabulary. We can run single containers. But a pentest isn't a solo act. We need a victim, an attacker. Running those one by one sounds tedious.
It would be. And that's where we transition to the next part of the notes, the conductor. This is why we installed Docker Compose.
How is Compose different from standard Docker?
Standard Docker plays a solo instrument. Docker Compose conducts a symphony. The key difference is that Compose manages services, plural. It reads a configuration file where you've defined everything, the victim, the attacker, the network settings.
And then it just spins it all up at once.
With one command, in perfect synchronization.
And that command is Docker Compose up IOD?
Let's parse that, because the AI is vital. It stands for detached.
What happens if we forget the DD?
Then the logs hijack your terminal. You'll just see this wall of scrolling text from every single container all mixed together.
And the moment you close that window,
you kill the entire network. Detached mode sends it all to the background and gives you your terminal back so you can actually work.
That seems like a critical safety tip. And when we're done, when we want to burn the lab to the ground.
Docker Compose down. This is one of the best features for a learner. It doesn't just stop the containers, it removes the network bridges, it scrubs the whole environment clean.
So every time you run up, you're starting with a pristine, fresh universe.
Exactly. No leftover configurations from your last failed experiment.
But since it's running detached, in the background, we're kind of flying blind. How do we know if an error happened?
You check the black box, Docker Compose logs. That will print out everything the services have been screaming about in the background.
Okay, I feel like we've passed driver's ed. We know the controls, we know the theory. Let's drive to the crime scene. Segment 4, the scenario.
This is where we move from theory to practice. The source instructs us to navigate to a specific folder, Demospentis.
This folder contains that docker-compose.yml file we've been talking about, so walk us through the launch sequence.
It's a 3-step checklist. First, Docker Compose up a D. You'll see the engine pulling the images, creating the networks.
Okay.
Second, Docker Epis.
Trust but verify.
Always. You need to confirm the containers are actually listed as up and haven't crashed. And third, we need to prepare our tools. The lab includes a container running Kali Linux, but the source emphasizes a specific scanner called OpenVAS.
Open Vulnerability Assessment System. That sounds pretty heavy duty for a home lab.
It is. It's an enterprise-grade vulnerability scanner. It's overkill, but that's the point. You're learning the real tools. Now, the source points out that while the software is installed, it's not fully configured yet.
I see a note here about an automatic configuration script.
Right. You have to shell into the Kali container and run that script. It updates the vulnerability database and sets up the admin user. But, and I cannot stress this enough, the source puts it in bold. There is a trap here.
A user experience trap.
A locked door trap. When that setup script finishes, it generates this long, random string of characters as the default admin password. It prints it to the screen exactly once.
Let me guess. People clear a screen and lose it?
All the time. And if you lose that password, you are locked out of your own scanner. There's no forgot password link here. You have to tear the whole lab down and start over.
So the note says, record that password immediately.
Immediately.
Once we have the password safely stored, how do we access the scanner? It's running inside a container, but OpenVAS is a web app.
Right, so we access it through the browser on our main machine. The Docker network maps it to https://localhost.9392. Or if you're using that GitHub Codespaces option, they have a ports tab that just generates a clickable URL for you.
Okay, so picture this. Our lab is humming in the background. We have our vulnerability scanner open. Now we need a target. The source introduces us to the victim, a machine at IP address 192.168.10.20.
The Metasploitable machine.
Is that exactly what it sounds like?
It is. It's a build of Linux that is intentionally broken. The developers have left every door unlocked, every window open, and turned the alarm system off. It is designed to be hacked.
Perfect. So we have a target. Segment 5 is the quick pentest. We aren't just going to look at it. We're going to break in. What's the first step of any hack?
Reconnaissance. You can't hack what you can't see. We need to map the attack surface.
And the tool of choice here is Nmap.
Network Mapper, the industry standard. The basic command is just nmap followed by the IP. It knocks on every port to see which ones are open.
The source suggests a more targeted approach, though. Nmap matches SV, Nash P21, 192.168.20.20. Let's break that down. Nash P21.
Port 21. That is the standard port for FTP file transfer protocol. We're specifically looking to see if the file server is active, a common entry point.
And Nash SV.
That is the service version flag. This is the difference between knowing a door is open and knowing what kind of lock is on that door. Nmap will try to talk to the service and get it to reveal its version number.
Why is the version number so valuable?
Because software vulnerabilities are specific. If I know you're running generic FTP, that's not much help. But if I know you're running VSFTPD version 2.3.4, I can go to a database and check if that specific version has any known holes.
And in this case?
In this case, the scan reveals it is indeed running a vulnerable version of VSFTPD.
Which brings us to weaponization. We know the vulnerability. Now we need an exploit. The source tells us to fire up MESC console.
The Metasploit Framework Console. If Nmap is the radar, Metasploit is the missile battery. It's a huge library of pre-packaged exploits.
So we're in the console. The prompt changes to MSF6. We type search VSFTPD.
And it will return a list of matching modules. We're looking for something that can turn that open port into a control channel.
The source says to simply use one.
That selects the first exploit in the search results. So now we have the weapon loaded, but we have to aim it.
Configuration. We set the RHOST's remote hosts to our victim IP, 192.168.0.2 header 0, and we set our port to 21.
The radar is locked, the missile is loaded, the target is confirmed.
And the final command is simply exploit.
The trigger pull.
I feel like there should be fireworks here, or, scrolling green text like in the movies. But the source mentions a quirk that happens right after you hit enter, something that freaks people out.
Yes, and this quirk confuses almost every beginner. You hit exploit, Metasploit says command shell session opened, and then silence.
No new prompt.
No C or rooted box. Nothing. Just a blinking cursor.
It looks like it crashed.
It looks exactly like a frozen terminal. And the natural instinct is to hit Control C to kill it and try again.
Which would kill your connection.
Exactly. You have to overcome that urge.
Yeah.
The source says, trust it. You are in. The system just hasn't sent you a welcome banner because you broke in through the back door.
So you're just typing into the void.
You type, whoa.
And if the void answers back,
it should reply with one word.
root.
I am root, the ultimate access.
You have total control. You are the administrator. To double check, the source suggests running unname to see the Linux kernel info, proving you are definitely on the victim box. We've broken in. We are root. But the mission isn't over. We need to leave a calling card. The source says to run touch iWash here.
Digital graffiti. The touch command just creates an empty file. By naming it iWasher, we are planting a flag.
But did it really happen? This is the full circle moment. We're in a simulation inside a simulation. How do we verify this wasn't just some glitch?
That's the beauty of Docker. We can pause the attack, open a totally new terminal window on our host machine, and log into the victim machine legitimately.
So we use our teleportation command again. Docker exec, metasploitable tube bash.
We enter the victim container as a standard user. We run alls to list the files.
And what do we see?
Sitting right there on the hard drive, iWasher.
That is incredibly satisfying. We used one container to break into another container over a virtual network, and we made a permanent change to its file system.
It demystifies the whole process, It's not magic. It's input and output. It's sending a specific string of data to a specific port and getting a shell in return.
And the best part is we did all of this without risking a single piece of real infrastructure.
Exactly. If we accidentally deleted the bin folder or corrupted the kernel, who cares?
Yeah.
Docker Compose down, it's gone. Docker Compose update D, and you have a fresh, brand new victim ready to be hacked again.
It really democratizes the knowledge. You don't need a server rack. You just need this one text file.
That's the key takeaway for me. This docker.md file lets anyone, anywhere, reproduce this exact learning environment. It creates a shared standard for practicing security.
Before we wrap up, I want to go back to that file, iWasher.
The flag.
It's so harmless, just an empty file. But the source uses it to make a point that actually gave me a bit of a chill.
It's a provocative thought. In our lab, we created that file specifically so we could find it. We wanted proof we were there.
It was loud, obvious.
But a real attacker has the opposite goal. They don't want to be found. So if iWasher's the trace of a friendly hack, what does a malicious hack look like?
Yeah.
Exactly. It looks like nothing changed. Maybe a system file has a slightly different timestamp. Maybe a process is using 1% more CPU than usual.
So the real question isn't, is there a file called iWasher? The question is, what files are here that I don't see?
And that is the paranoia that keeps security engineers up at night.
On that cheerful note, we're going to close the lid on the Hacker Sandbox for today. Thanks for joining us on this deep dive.
Stay safe out there.
Until next time.